In this video, we're looking at the power rule property for logarithms, which says that if we have the argument of a logarithm that is being raised to some power, that power, that exponent, can be brought around to the front of the logarithm as a multiplier. This rule is not entirely intuitive, so we're going to prove it. This is a proof by deduction, which means that we're going to be starting with the left-hand side of this property and make smaller steps that are easier to follow in order to hopefully generate the right-hand side. So here we go. We're going to say log base A, and we're going to expand this argument to be m times m times m. This is basically what m raised to the p power is if we were to have p m's multiplied together, right? M times m is m squared, m times m is m cubed, and if we do that p times, then we're going to have m raised to the p power. Now we're going to employ the property that is the power rule. Remember that if we have a logarithm with two things multiplied together in the argument, that can be expanded into the sum of two logarithms, where the first log is going to have an argument that matches the first factor of the original argument, and the second log is going to have an argument that matches the second factor of the original logarithm. So if I have a product, I can split that up into the sum of two logarithms. So we're going to employ that here. We're going to say in this logarithm, I have a product of a whole bunch of factors, right? So I'm going to split this up into the log base A of the first factor plus the log base A of the second factor plus, and I keep going because I have p factors, so I'm going to end up with p of these values that are being added together. And let's recall also for a moment that if we have x times x times x times x, that's going to be x raised to the fourth power. But if I have x plus x plus x plus x, that's going to be 4 times x. So if I'm adding a bunch of things together, that's going to be 4 times that thing, or however many of those x's I am actually adding. So I have log base A of m plus log base A of m plus log base A of m, and we're doing this p times. So what this ends up giving us then is going to be p times that log base A of m. And essentially that is the second side of the property that we were trying to prove. So let's kind of come down here with an overall conclusion statement that says that if I have the log base A of m with that argument being raised to the p power, that will be the same thing as p times the log base A of m. We can think about taking this exponent of a p and just bringing it down around to the front as a multiplier on the front of the logarithm.